Hi, welcome to Couchbase Connect Online 2021. My name is Enrico Pagayukin, and I'm a solutions architect at Couchbase in the professional services team. Well, I switched to professional services because I love helping customers get the most value from their implementations. I did start my career as a developer, and today I'll talk about how to get started using Couchbase Java SDK 3.2, the Couchbase Transactions Library, and Spring Data Couchbase using a very simple Java application. I'll describe the prerequisites for our sample Java application, how to prepare it, how to connect to the Couchbase cluster, and I'll explain the logic in the main code sample for this presentation. We'll use a Couchbase Server 7.0 cluster with one node. For this exercise, our single node will have the data, query, and index services enabled. This practice of co-locating multiple Couchbase services on one node is acceptable for development purposes. However, in production, the best practice is to put the individual Couchbase services in their own nodes. For example, we might have 4 data nodes, 2 index nodes, and 2 query nodes in a production cluster. Our IDE will require at least Java 8. We'll need 1 bucket on the cluster. And for now, we'll use the default collection that comes with the bucket. Lastly, we'll create a primary index on the bucket. To generate our Java project, we'll use Spring Initializer at start.spring.io. We'll package our project as a jar and add the Spring Data Couchbase dependency. Clicking the Generate button will download a zip file to our work environment. We'll extract the downloaded zip file and create 3 classes and 1 interface, as shown in the screenshot. Next, we open pom.xml in our IDE, add the Java SDK and Transactions Library dependencies, then reload pom.xml to make sure the dependencies are loaded. Our first class is Couchbase config.java, which has our bootstrap information, including the cluster hostname, connection credentials, and bucket name. We use the default collection for this exercise, but as you get familiar with Couchbase scopes and collections, by all means use them in your applications as they're a more powerful and efficient way to organize, index, and query your documents. Lastly, we'll create a single transactions object with configuration details that we can customize, but for this exercise, we'll use the defaults. Our app uses a very simple data model. In this case, a customer entity with common attributes like first name, last name, and so on. The only mandatory annotation is @document, and it signifies that our customer entity will be persisted as a document in Couchbase. We typically use the @ID annotation to tell Spring Data which attribute will be the document key. But in this example, because the attribute name is ID, SDC, Spring Data Couchbase, will automatically recognize that attribute as the document key. Customer repository is an interface that extends Couchbase repository, and it's a mechanism to perform operations on our customer entities. We declare the methods for the operations that we need, and the supporting queries and/or key value method calls will be generated automatically. Note that the findAll method has an additional scan consistency annotation set to request plus. This means the query behind the findAll method will wait to execute until the index supporting the generated query is fully updated. This essentially means the ability to read our own writes, although request plus will result in a higher latency. The last method, find customers with zip, does not generate its own query. Instead, we use our own query with the @query annotation. Note that this query also uses a named parameter, zip, specified with the @param annotation. Our main code is in the run method of the command runner class. For our application test runs, we first delete previously created customer documents. Then we create 5 customer documents, where each document key is generated using a prefix of CUST colon and a globally unique identifier with the dashes removed to save us a few bytes. Next, we execute our repository methods to demonstrate their use. Find all and find by ID are CRUD repository methods. Find customer by city and by zip are customer repository methods. And the last method call is also a customer repository method, but uses our custom select query. Next, we make 2 calls to a custom method that shows the use of the transactions object. In short, the custom method updates the notes field of the customer document given a specific city. But for demonstration purposes, we use a Boolean flag that allows the transaction to either complete successfully and commit the changes, or fail and roll back its changes. This is our custom method, and it has 2 parts. Part 1 is shown in this slide. First, we use a nickel query to get IDs of customer documents where city is equals to Chicago, or our specified city. The query uses a named parameter, city, and we use a query options object to set the named parameter, where we also set ad hoc equals false, which tells the query engine to prepare the statement once, so it won't have to prepare it again on subsequent runs of the query. In part 2 of our custom method, we do a key value get of all customer documents with the IDs that we retrieved with our nickel query in part 1. We make a working copy of each customer document that we fetched, mutate the working copy. In this case, we set the notes attribute to some value. Then we replace the customer document in the database with the working copy that we just mutated. Note that all of these mutations occur within a transaction. This means that if an exception occurs, the transaction is rolled back and the documents are reverted to their original state. Also note the block where we could intentionally fail the transaction for testing purposes only based on a Boolean flag. And finally, note that the transaction is committed by default unless an exception occurs. And now I'm going to show you what this looks like in action. First thing I'll show is the Couchbase UI. And we can see that there's our cluster with 1 node, and it has the 3 services on it, data, query, and index, for our development purposes. We don't have a bucket yet, so I'm going to go ahead and create one. And this bucket also does not have any indexes on it yet, but for development purposes, we're going to create a primary index on the bucket. Note the use of the backticks. They are required when you specify the name of the bucket. So we just created our primary index, and it should show up here. And now we're able to query our bucket. Now I'm going to switch to my IDE. And these are the 3 classes, or 2 classes and 1 interface. This is our configuration with all the bootstrap. Our customer entity with the @document annotation, which will persist the document in Couchbase. And our customer repository interface with our declared methods, as well as command runner. So what does this look like when we run it? And there it is. So the first block here is our find all method. And this is, again, a repository method. So we didn't have to define the method itself. We just needed to call it. And it returns all 5 records from our bucket, customer records. The second call is a find by ID. So we supply an ID. And of course, it returns 1 record or 1 document. And then the next 2 are similar in that they're both repository methods, and they're both generated. They both generate their own queries, signified by the by keyword: find customer by city, find customer by zip. And this is the method that we defined our own select query: find customers with zip. So going back here, there's our select query. And lastly, we have the 2 calls to the custom method where we perform a transaction. The first call completes successfully because we allowed it to using our Boolean flag. And then the other one, we failed on purpose to demonstrate what happens. Now I'm going to switch back to the bucket and take a look at our documents. So you can see that there are 5 documents that were created. If we pick any one document, we'll see that there's our we generated our document ID. And this attribute and value were automatically inserted by Spring Data Couchbase. And I'll have a little bit more detail on that in another slide. Our 2 calls to the method with the transaction. Note that we have 2 customers from Chicago, and in both of them, in both records, the notes field were mutated, versus the 2 customers from Washington, where the notes field was not, the attempted mutations were reverted because the transaction failed. A few caveats to point out. First, as I showed earlier, Spring Data Couchbase transparently adds a underscore class attribute to each document it creates. It is possible to customize the name of this attribute and the value that is inserted by the SDC by overriding the type key method in Couchbase config.java and adding a type alias annotation and custom type value to the customer entity. Second, the transactions library also creates its own meta records in the bucket. Lastly, a word of caution about primary indexes. Primary indexes should strictly be used for development purposes only. They should never be defined nor built in your production clusters. A primary index contains only document IDs. It allows queries to fetch all documents of all types in the entire bucket and process them against the query predicate, which is highly inefficient and incurs significant load on the cluster, especially when you have potentially millions of documents in a bucket. Therefore, only use a primary index to get started developing with Couchbase. For example, when using Spring Data Couchbase for the first time, or when you're just getting started with Couchbase queries. The best practice is to create global secondary indexes, or GSIs, that will support all of your queries, then delete the primary index on your bucket. Please make sure to see our best practice guide on nickel tuning with very useful tips and tricks. We have extensive documentation with more details to help you get started. First, we have our official doc site with details on the Java SDK. The SDK document has a section with details on transactions and a document on using global secondary indexes. Reference documentation for Spring Data Couchbase is available on spring.io. Developer.couchbase.com has the best practice guides to help you optimize your Couchbase implementation. And particularly these guides, data modeling, document management, and especially the nickel tuning guide will help you optimize your indexes and queries. Blog.couchbase.com is frequently updated with new articles organized by topic and specialization. And there's also a public Couchbase forum that might be helpful as well with commonly asked questions. And lastly, highly recommended are these training courses available at Couchbase Academy, where CD 212 covers basic nickel and CD 410 is the advanced version and goes in much deeper detail. We also have a comprehensive Java developer course, CD 215. That concludes our developer quick start. We talked about how to get started using Couchbase Java SDK 3.2, Couchbase transactions, and Spring Data Couchbase. Thanks for your time and see you in the next session.